Hello everyone, welcome to my channel. So today we are going to Leetcode daily challenge Pseudo-Palindromic path in a binary tree. So we are given with a binary tree and here we are required to check for a Pseudo-Palindromic path. And now comes the question that what is Pseudo-Palindromic path? So for that, let us read the question. So given a binary tree where node values add digits from 1 to 9, a path is in the binary tree is said to be pseudo-palindromic if at least one permutation, means at least one permutation of the node values in the path is a palindrome. So the thing is that whatever path we are choosing in our tree, in that if we do at least one permutation, then it becomes a palindromic path. We all know that what is a palindrome. So basically a palindrome is if we traverse that particular path and if we got into the middle of that path, right? And if we put a mirror in that, so or if we stand there at the middle of that particular, right? So if we see from that particular path towards the left or we see towards the right, both of the things which we see would be similar only. So what I'm saying is that we all know that palindrome is something like this. Means if we stand here, then if we see here or if we see here, from here to here, from here to here, everything would be similar. Or if there is something like this, like 3, 2, 1, 2, 1, or something like this, 2, 2, 1, 2, 2, 1. So like this, here these are the middles, right? So here also same thing is there, here also same thing is there, here also same thing is there, here also same thing is there. So that's the thing. And so in that context only they are saying that if we do at least one permutation, then in that context it will become a palindrome. So this is they want to say. So now comes the part that what this question wants us to do. So it wants us to return the number of pseudo-palindromic paths going from root to node leaf. Root node to leaf nodes. So basically in this question, here is the root node and here is the leaf node. So this is one path, then this is second path, then this is third path. But we need to return only those paths where it is a pseudo-palindrome. So here you can see that this particular node path and this particular node path, both of them are pseudo-palindrome. That will check and I'll explain you more on the same. But before that, let us see the constraint of this particular question, then we'll go ahead. So constraints of this question is that the number of nodes in the tree is in the range 1 raised to power 10 raised to power 5. So that simply says that we can't do n square solution, we can only do n or n log n because it is 10 raised to power 5. So 10 raised to power 5, if we do n square, then it will become 10 raised to power 10 and that is not acceptable here. And value of each node is 1 to 9 only. So that simply means that it is not like 10 or more. But still, even if value becomes much more than that, would there be some effect? And yes, there would be on that bits part only, I guess. Yeah, okay. So presently, according to lower constraint of this node dot value and even this particular like this, so we can do one method in the same because let me show you first explanation part there only I explain. So here I've drawn this particular, yeah. So here you can see that this was from the first example, this was from first example and this is from the second example. So here you can see that if in this particular we are having this 1, 2, 2 as the one path and then 1, 4, 4 as the one path. Here the speciality is that only one is that particular where the occurrence is single and all are double, and here also all are double. So basically there should be at least one occurrence which is the single in nature and all other occurrences should be even occurrences. Basically one odd occurrences and all others should be even occurrences. So here also you can see that 2 is having the odd occurrence and 1 is having the even occurrence in this particular path. And here in this path you can see that 2 is having odd occurrence and 1, then 1 and 3 both are having even occurrences. So like this, here also 2 paths are there and here also 2 paths are there. Now comes the next part, that how we can do this question. So basically this question could be split into few more sub-problems. Then we can do this. First thing is that first part comes is like how we are required to get our paths. Means in general how we are required to get our paths. So for that purpose we would be traversing our trees, right? So for traversal we can use any sort of traversal. So that is the first thing. Now the second sub-problem is that we are required to check that how many bits are being set, right? According to that only we can figure out that these much bits are set till now, so these are the odd and these are the even, so we can go ahead or not. And the last thing comes out that at the end how many bits are set or not. So that's the thing. So basically this problem is split into further 3 sub-problems, and according to that only we will be able to figure out with the ultimate solution. So now let us go to that. So here comes the part, those 3 problems which are being there. So the thing is that first sub-problem is that we are required to check paths from root to leaf node, right? I don't know if there is some question or not, but this becomes a question itself, that we are required to return all the paths from root to leaf node. And there is no specialty in that, only we are required to return that. But the thing is that we won't be storing anything, we will be just checking for a path, and in that only we will be performing operations. And here the second question becomes, in a path we are required to check bits on fly. The thing is that while we will be checking for the paths, right, in that manner only we will be checking that if that particular bit is set or not. So that becomes another question which we have already done, that how to check a set bit or not. Now check for only and only one bit is set in whole path when we reach the leaf node. So this is another question, that how we check for this particular purpose. We used to check for this particular purpose by checking that if that particular number is basically power of 2 or not, because whenever a number is power of 2, then in the whole bits of that particular number only one bit would be set, else no other bit will be set. So that is why this problem is being split into 3 sub-problems. So now comes the part that how we are required to solve these 3 sub-problems. So for that purpose, here's the thing. So for the first part, there is that we can do any order of traversal, right? That is the thing. See, the thing is that we are basically traversing a tree. In that traversal of tree, it's our choice that we are going to go ahead with DFS or DFS, and that choice is also determined that what sort of question is it. Here we are required to go from the root node to leaf node, right? That we can go either from DFS or DFS, right? But now comes the part that which will be faster mode. Would DFS be the faster mode or DFS would be the faster mode? So in that context, the DFS would be the faster mode. Reason? See, in DFS it will be level order traversal. Means it goes from first level, means the root node. Then it comes to the second level. In that second level, there would be 2 children of that particular root node, right? Might be 2 children, but at most, yes, there would be 2 children because this is a binary tree, right? So when there are 2 children and it is a level order traversal, so what it will be doing? It will be going from root, then to its 1 children and the second children at that level. So like this only, it will be going down, 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 right? But it will be going down in that manner only when in the second level, we are having 2 children, then in third level, at most there would be 4 children, right? So it will checking for all 4 children, right? So that is the thing. In this DFS, we will be taking more time. But in DFS, we go to root, then it's first child, then next level first child, then next level first child. So like this only we will be directly going from path, root node to leaf node. So that is the most fastest way, right? So that's why according to this question, doing DFS would be the best mode. So that's why we are doing DFS here. what I was saying was like this. Means here is the root node and here is the leaf node. In DFS we will be going directly, but in the BFS we will be going here, then here, here and then here, here and here. It will be completely a zigzag manner. So you can say a zigzag manner, but it would be something like this, and basically something like this. If we make a proper tree, I hope you would have understand, but I'm trying to explain it more clearly. So the things would be something like this. 1 minute. So in the BFS, it would be going from this root node to this particular node, and then it will be going here. So that would be the scenario. Then it will be going here and it will be going here. That would be the scenario. And for this particular node, it will be going here and here. So like this, it will be able to check for all the nodes. Means the path won't be straight like this in the way it is in DFS. So that's why here we will be preferring with the DFS. So this was for our first subpart. Now comes the second subpart. So second subpart is for checking the number of bits, because for checking the number of bits only, we are required to check that at most 1 bit is being set. So now here use the bit operation, here checking set bit by usage of XOR. So we know about this XOR property, that XOR is basically like that if we do XOR, so XOR returns 1 only when both of the bits are 0 or 1 0. Then our answer would be 1, right? And it returns 0 when both of the bits are same, means either both are 0 or either both are 1. So we will be using this property only, and this property will help us to determine that whether we are having the odd occurrences or even occurrences of that particular bit. So that's why we are checking that bit is set by XOR operation. As we could have also used the AND operation, but AND operation is basically used for checking just a single bit is set or not. But XOR operation can be easily used for checking multiple bits are set or not, because what I mean by multiple bits here is that bit for a particular number, bit for second number, bit for third number, and these 3 numbers are basically different. So that's why we can check with the fly for various numbers that their bit is set or not with the help of XOR. So that's why we are using XOR here. Now comes the next part for checking that if this particular is having only 1 bit set or not. For that purpose, we will be doing same the way we do for checking that if that particular number is power of 2 or not. Because the thing is, for power of 2, as when a number is power of 2, then only 1 bit is set in whole, and it is easily able to check by AND of present bit and present minus 1 bit. So that's why the third part of this question would be this, like this. So the thing is that how we came up with these 3 subparts was simply by like this, because in a particular tree we were required to check for a path, and in that path only 1 bit should be set. This was the problem, right? And why we were choosing like this? Because we were required for a pseudo path, pseudo-palindromic path. So that's why we have chosen as the problems like this only for this whole problem. And this is why we have splitted our whole problem into 3 subproblems. So now comes the part for the time complexity and space complexity. But before that, let us go through all the subproblems and check that what we would be required to do. And accordingly we can check. So here you can see that in this first part, we are just traversing. And traversing a tree takes order of n time complexity. Order of n time complexity, right? So that's why here time complexity is order of n. Then comes the part for checking this. So this would be 32-bit operation only, right? So that's why it takes order of 32, that is order of 1. And this particular is also order of 32 only, so it's again order of 1. So overall our time complexity becomes order of n and space complexity. As we are doing second step and third step, with slide, right? And first if we are traversing the tree, that is basically using DFS. In that DFS, either we can use iterative DFS or recursive DFS. So in both of the scenarios, we will be using either a recursive stack or a iterative stack, right? So that stack will take the space up to height only, right? And that height could be at max order of n. So that's why space complexity basically becomes order of n again when a tree is a skew tree. So this was all for this particular question. Now comes the part for the coding of this question. So here's the coding part of this question. I know screen is small to be visible. Let me increase size. So here comes the coding part of this question. So here we are starting. So basically what we are doing here is, so here we are having pre-order, and then we are having the count which we are required to return at the end. Return the count, basically the number of paths. And this pre-order is basically we are traversing this particular tree. So while traversing this tree, this is the thing which we will be doing. So how we are traversing? We are taking that if node exists, means basically node is not equals to null. If it would have been null, then we would have directly returned the count as 0. So that is the thing. So now first we are basically checking for the path. In that path we are doing the XOR operation for each and every bit which is being there. So at the starting our path would be 0, right? Basically when we are at this 2, right, so our path is basically here as 0. We have started from here as 0. You can check, right? So whatever node value we are having, so node value is basically 2, right? So when we are having node value is 2, so let's say something like this. And when we do node value and left shift the 1, so 1 would be at this particular point, right? So when we left shift it by 2, so then in that scenario it will be here, right? And when we do XOR operation for the same, so it will come out to be wait a minute. So this was what I'm doing, seriously. Yeah. So when we do this is what after doing the left shifting, right? So this is that particular, and at the starting our path was this one 0, right? So we are doing XOR with the same. So when we do XOR with the same, so now it becomes 0 1 1 0, right? Because these two bits are basically in that order, what we say as means both of these bits are in different manners, right? So when so only this bit would be set, right? Now our path becomes something like this, right? So this was single occurrence of a digit. Now when we go ahead with 3, right? So what is for the 3? So for 3 we are having something like this, means 2 raised to power 1, that is 1. This would be set and this would be set, right? And this is for the 3. So when we left shift R1 with this particular, then it would be something like that. Here when we do that XOR operation, right? So in that particular scenario, here it will be set and it will be something like this only. And then again when 3 comes, then again this particular thing will repeat itself again. So in that particular scenario 1 would be there, right? So here again it becomes 0, so only one bit will be set at the end, right? So in this whole path only this particular would be the end result, right? So only this particular bit is being set at the end. So this would be the scenario. I would have been wrong in doing that left shift. No, but I am not wrong. The thing is, because when we do a left, when we were checking for the bit, means when we were checking for ith bit, then we used to do I minus 1 bit shift, right? Here we are in that manner only. So here we are not doing node val minus 1 for checking that particular values bit is set or not. Here we are directly setting it by that only. So that's why here you can see that here it is 2 raised to power 0, 2 raised to power 1, and then 2 raised to power 2. That is when it now at the end it becomes 4 rather than 2, although only this particular bit is set. So this will be the end answer. Now we are required to check, because now we have reached our leaf node, right? So at this particular moment of time, we will be checking that at this moment of time is our leaf node means path till now, because this would have been stored in path only. So now we will be checking is this power of 2 or not. So now we can clearly see that this is power of 2, right? And this shows that it is what is it? There is only one bit which is being set. So that's why how we are doing means we will be doing this whole with the fly the way I have showed you by dry run. Then when it reaches the leaf node, means when it reaches at this particular node, here we are checking that if it is a leaf node or not. Then we will be checking that particular question only which we used to do, that if it is a power of 2 or not, by checking that path and path minus 1 by doing AND of them. If it is equal to 0, then we have found one path, and that path we are incrementing the count. And then we will be traversing our whole tree. As we are doing here pre-order traversal, so that's why we are processing the root at the first moment only, and then we are going in the left and right subtree. So this is the whole coding part of this question. From this only it is being clear that is order of n time complexity, order of n space complexity. So yeah. This was all for this particular question. If you have any doubt, you could comment that down, and if you like the video, then please do like and subscribe to my channel, and please do share among your friends and so on. So this was all for this particular question. So thank you.